Hi, my name is Bob. This video is going to be an introduction to the SQL language, structured query language. I'm intending to release about 12 of these 1 week at a time. And I'll go over what we're going to be teaching, basically the full SQL language, as well as how it can be used in the area of, say, full stack applications, and also as part of data and artificial intelligence. SQL is a major component of artificial intelligence. It is also a core part of the back end on nearly every full stack application. A little about myself. I have over 30 years experience with SQL, including advanced queries. My experience includes databases like Oracle, where I started, Microsoft SQL Server, MySQL, Postgres, and now also BigQuery, Google BigQuery. Originally from New York, I started my career in 1992 working for Apple Computer in Cupertino, and have lived in California since, working for companies like Sutter Health, Accenture, Meta, General Electric. Most of my career was at Sutter Health, 24 years working with clinical data, which is very complicated data because the human body is complicated. My teaching experience includes about 10 years at various colleges and universities in the Bay Area. So what we're going to be talking about is the full SQL language. The focus will be more on the select command because that's kind of the core, particularly when it comes to data analysis. But the entire language is going to be taught, and also talk about how it's used in both full stack applications and also as a core technology for data and artificial intelligence. Some aspects of the language we're going to go through is being a filter languages, the where clause, using wildcards, specifying columns and column aliases, sorting data, limiting the number of rows you get back from the query, um, set operations, subqueries, talking about some things like primary keys and foreign keys and normalization, how to do joins, the different aggregate functions that are widely used for data analysis, views, and a whole bunch of stuff that we're going to get down to. Also, things like various types of functions, also the use of stored procedures and how they're very valuable. User-defined functions. Also, we're going to talk about connectivity to other languages. Some of the popular ones are Python, JavaScript, Java. There's other languages as well, but those are probably the top three most popular. Python in particular is also a core technology of artificial intelligence. Python can also be used on the back end of a full stack application. JavaScript is generally used can be used both front and back end of a full stack application, and can connect to the database. Java has been a popular one as well, although I think it's fading in popularity. We'll talk about, again, a full stack application in many cases would be a web front end. It could also be a mobile front end. We'll look at some graphic tools like the D3 library that helps you display data in a graphical format. And we're going to cover all the commands. So in addition to the select command, what's known as the DML or data manipulation language is also made up of the insert, update, and delete commands. Um, Extras, I think we actually will get to these stored procedures, connectivity. Again, languages. SQL doesn't exist in a vacuum. It's generally a very core part of applications, and also data analytics. So it's got to be able to connect a language like Python, Java, JavaScript, for example, needs to be able to connect to the database and execute queries. In some cases, if it's a web application, a web front end, the results of those queries will be displayed on a web browser. And this would also be true of a mobile phone, like an iPhone or an Android, either through a native app or just simply a mobile-friendly web app. Talk about data and AI, right? This is core. Python and SQL are two of the top languages for data and artificial intelligence. Those two languages are also core in full stack applications as well, not just data and AI. When you're talking full stack, you're probably going to have to add JavaScript to that as well. I'll talk briefly, if we have some time, the difference between SQL and NoSQL, a NoSQL database like Mongo. So getting started, the SQL language is made up of four sub-languages. The first one, and the one we're going to focus on over the next 12 weeks, is the DML, or data manipulation language, which is made up of four commands. The select command for reading data, the insert command to create data in a table, the update command for updating data in a table, and the delete for deleting from a table. Now, these four commands also map to what's known as the CRUD operations. And you hear a lot about CRUD operations and full stack applications. CRUD, the C in CRUD is create. That maps to the insert statement for SQL. Read, R is read, and that maps to the select. Now, update and delete map to update and delete. There's no translation necessary there. Some of the other languages you have are the DDL language, which is data definition language. Create commands like create, alter, and drop. DCL, which is the data control language, like grant and revoke. This is for permissions that users can have or taken away. The fourth rather, is DCL, or transaction control language. This is more applicable in full stack applications. And this is things where a transaction, like you're selling something, for example, requires multiple updates to multiple tables. Like you're updating a customer table, a sales table, so, things like that. You have multiple updates, and all of them have to succeed in order for the overall transaction, to be considered a success. If one of them fails, they all have to fail. So transaction processing allows you to group SQL commands together and say, even let's say the first two succeed, if the third one fails, you have to do what's known as a rollback of the prior two. So a transaction allows you to put the SQL commands into sort of a soft save, a status. And then if they all succeed, what's done is known as a commit. And the commit is like a hard save of the changes. If they have not all succeeded, you can do a rollback. And since they're only in a soft save, you can roll back the change. So this is very much important for full stack applications, not so much for data analytics or artificial intelligence. It's not important for that, since those types of processes are generally just a querying the data. Okay, so the first basic command we're going to see in just select asterisk. The asterisk means all columns. If you see a select star from table, that means give me all the columns and also all the rows, saying give me everything from that table, right? The asterisk means all columns. So a very simple one is select star from items. Now I'm using MySQL for this example. That's probably one of the most popular databases. There are others as well, like Postgres is also very popular. Even like Google BigQuery. Maybe I'll try and show some stuff on that as well. Google BigQuery is Google's sort of data warehouse database. But what it is it's SQL in the cloud. So you'd have a database in the cloud, and you'd be using SQL to access and manipulate that data. So I'll go over to my database here. Here's the items table. If I'm just doing a right click here in MySQL, and it gives me all the data. That's select star, everything. Gives you everything from that table. Now you can limit the columns you want. For example, I can say, I just want the description and price. I don't want all this stuff. So I can go back to my query here and change this. And I want description. What did I say? Description and price, I think I said in this thing. Description and price. Okay. Description and price. Price. Now I go ahead and execute that. And then I get just those two columns. So this is now, it's no longer select asterisk. It's select two specific columns from the items table. You can also limit the rows, right? The rows. The where clause allows you to limit the rows. It's like a filter. And the filter here is saying, I only want items with a price greater than 500. So if we go to here and we'll go back to asterisk, it doesn't matter. I can just leave that there. I don't have to remove them. So what we're doing is now we're limiting. And you see, we've got, just looking at it before I execute the query, you can see that two of them would have a price above 500. And this third one, sport coat, is only $100. So my where clause that I'm going to use should limit. So when I execute it, we should no longer get this sport coat. And voila, sport coat's gone. Now I could say here above 1500. Come on, there we go. Hello, 1500. Now I should no longer get this Dell laptop because it's exactly 1500. It will be left out because it says it has to be greater than 1500. So we'll go ahead and execute this one. And voila, it's gone. Now, if I wanted to say, well, greater than or equal to 1500, I could say, put an equal sign there. And that's greater than or equal to, and now we'll get our 1500. Da-da, there it is. So those are some examples of a where clause. Where clauses can get a lot more complicated than that, and we will get into some more complex examples. Here's one. This is called a compound where clause. So now I'm saying, give me everything where the price is greater than 500 and the quantity is greater than 90. This is called when you have more than one condition, it's called a compound condition. So first of all, let's just go back and grab everything again. And no where clause, I'll get rid of that. So the where clause says greater than 1500 and quantity greater than 90. Okay, so that's a where clause. It's greater than. So even though this one has 90, it will be excluded because it has to be greater than. So we'll just take this where clause right here, copy it over here. Ooh, what happened? Copy didn't work. Copy paste didn't work. That's because I'm on a Mac. Okay, we executed. So now you see we only got the one that had that greater than 1500 or greater than 500 rather, and a quantity greater than 100. Now, if I wanted to say, well, greater than or equal to, I put the little equal sign in there, execute it again, and now we get it because I added the equal. When you say just greater than, then that 90 there is left out because it's not greater than 90. All right. Okay, so this is the example where it shows compound where clause. We just talked about that. There's an order by as well. So you want a lot of times you want to order the data. When we do and just adding the order by, and I'm also adding ascending. ASC means ascending order. So that's going to be from the lowest to the highest. Now, ascending is the default order and condition, so you do not have to put that in there. We'll take a look at this one. Oops, do that again. Oh. Ah, there we go. If I execute this, you see we got the prices from lowest to highest. Now, ascending is default, so I can leave that off, and I'm going to get the same result. Okay, 100, 1500, 3000. Now, what if I want to go the opposite? Descending order. Type in descending, DESC. Execute. And now you got the highest price to the lowest price. So you can order it in any direction. Okay, here's the example of descending order. Just went over that. You can order by multiple columns if you want as well. So that's perfectly fine. That works as well. All right, so and you can put descending here. So you get it in descending order there. Descending by price. You can limit the number of rows you get. So if you got a really big table and you only want to get a sample of maybe 100 or something, you can put a limit. So right now, if we do, let's take this here. Oops, limit 1. There it is. Limit 1. You only get 1. Now, what you can also do is you can say, maybe you want to see the highest price item. You can say order by price descending. And you get that. Well, maybe you want the highest or the lowest price one. I can just change that to ascending. And now I get the lowest price one. The next we look at what's called the like. The like allows you to do a pattern match. It's called a wildcard, but it's a pattern match. So some examples would be like ice percent. That means the column value starts with the word ice. Signs between 2% sign means the column contains signs. Percent signs means that the column value ends with signs. Now I'm going to go to another table here they got a little more data. My products table. Let's take a look at the products table. And actually, I already have it open. Let's just close it. Here it is, my products table. We'll take a look at that. A little more data. So now we're going to use the like clause, a couple of examples here. I'm saying where skew, which is this value right here, is like WOO%. So coming to the data, just eyeballing it, we see that most of the columns actually do begin with that, but not all of them. So we're going to do two versions of this. We're going to say select everything from that products table where the skew starts with WOO. That's basically that's what that means right there, like WOO%. I'll paste this in. All right. And we get a bunch of most of the data. You can also say not like. And you'll see there's only two rows. Right? So there's only two rows. And if we eyeballed the data, we'd see that's true. Right? Now let's look at another example in that same table. We're going to say where the name percent shirt percent. What that means is that the data, let's look at the full data now. That's this name column right here, contains the word shirt. So the column has to contain the word shirt. So let's go ahead and put that in. Okay. And we'll look at it. Everything in here, you got shirt over at the end, shirt at the end, shirt in the middle here, shirt in the beginning. So but this name contains because it's between percent signs. The percent sign means 0 to many characters, match 0 to many characters, any character. Again, so in the beginning and the end. So essentially what this means is that this field name right here contains the word shirt. Now, SQL is not case sensitive by default. So you see a lot of these shirts are uppercase shirt. Doesn't matter because by default, SQL is not case sensitive. You can make it case sensitive by default, but by default, it is not. Now I can switch this around just like I did the other time, and I can say, give me all products where the name does not contain the word shirts. And now we get everything with everything else, right? If you want to say, hoodies, right? You say you can put it here, you can change shirt with hoodie. And note, hoodie here is uppercase H. I'm typing it all lowercase. Does not matter because SQL is not case sensitive. Not by default, anyway. Okay, here's the not like example. The next one we're going to look at now is called distinct, which gives you the distinct values for a column. Now, going back to our database, and we're going to look at the full database again, or the full everything that's in there. What am I looking at? I'm looking at type, distinct type. If you look over here, you've got a column that says type, and there's some values in it. You see variable, variable, simple, simple, variation, some grouped, external, and there's multiple rows for each one. But what I want is I want the distinct. So distinct means just one for each. Nope, this should be select. I missed select. What? Oh, get rid of that. Okay, each distinct. Even though each one had multiple rows, we're going distinct. Next, let's start looking at some aggregates. There's actually 5 aggregates. The first one we'll look at is count. So I just got distinct type, but what if I want to know how many items are of that type? You can use the count. It's called an aggregate. An aggregate applies to multiple rows, and it performs some operation over those multiple rows. Aggregates work with what's known as a group by. So you have to create groups. So what I'm doing is I'm creating groups based on type. So each type is going to be put into its own group. And this count function is going to count for each group. And in the end, we're going to get a result looks like this. So that means I've got 2 products of type variable. I've got 12 of type simple, 2 of type simple downloadable virtual, 7 of type variation, 1 of type group, and 1 of type external. So let's take this query here, go over to our database, and execute it. Okay, you get that there. So in the aggregates, I mentioned there's 5 of them. We just looked at count. There's also a sum of a numeric column. AVG is an average of a numeric column that meets the filter. Same thing, the minimum, the smallest value, and the maximum value. So if we do something like this, I'm going to look at back in our product table. You have to have a table that makes sense to look at. And let's just put this back to star. Get rid of that. And let's look at all the data again. Now, if we scroll over here to the right, we will see we have regular price. So, and that makes sense. Aggregates normally work against a numeric field. That's typical. Not count, but the other ones typically do. So we need to use it. And amounts are very common. You're looking for things like, the sum of maybe how much you received in a given period or from a given customer or something like that. We use sum. You're looking for the lowest and the highest price and then the average. That's fairly typical. And a lot of these aggregations are used for reports, report generation. A sales report, for example, used in that. Also very commonly used in artificial intelligence. Artificial intelligence works by very large data sets, analyzing very large data sets. And that's really where SQL excels, which is why SQL has become a core technology of artificial intelligence. Put this in here. And we'll execute it. Okay, voila, we got that right there. Now, that's just raw data. But you see, for each type, we have how many, what was the sum of sales. So this variable had no sales. The group didn't have any either. That might be important. That might tell, management, well, maybe we shouldn't be wasting our time trying to sell this stuff. Or maybe we need to do a better job trying to sell it. So this aggregated data would wind up typically in a report to management, and they might make a decision, a strategic decision based on it. Very common. So we've got the sum, we've got the minimum and the maximum amounts. That'd be the range, and also the average. Okay. That's it for this session. Like I said, I plan on posting 1 a week, probably 12 weeks, could go longer. And it's all going to be on the SQL language, and also how SQL is used. Like I said, SQL doesn't exist in a vacuum. It's a core part of things like full stack applications on the back end. SQL is part of the back end, right, of a full stack application. It's also a core technology in artificial intelligence. It's used for data analytics, data analysis. Just about every major company out there you could think is using a SQL database. You go to Amazon, you search for something, you search their inventory, you want to buy something. That's ultimately going and executing a query against a database. Search for skis or something. All right, and that's ultimately going to go to their back end to search their inventory using the SQL language to find that product to try and sell it to you. And we'll get more into that. This is session 1. I'm planning 12 sessions, 1 per week. Thank you very much.